So far we've talked about charging by friction and charging by conduction. Today we're going to talk about charging by induction. So if you haven't already, make sure you watch the two videos linked on Schoology about the electrophorus. If you don't see those on Schoology, that's okay. Just go to YouTube, search up electrophorus demo, and you'll be able to watch it. They're all pretty much the same. I'm going to do the demo in class as well. So after you watch the demo, come back and fill out the notes. Okay, hopefully you watched the demo, and the first thing you notice in each of the demos is that someone had to rub some kind of a base plate with fur or silk or something to charge up the base plate. And the one we did in class, and it could be different from the demo that you watched, but the one we did in class, we had an acrylic plate, basically a plastic plate, and we used rabbit fur. So in that case, because of the Trev Electric series, I know that the base plate is going to become negatively charged. And it becomes negatively charged because of the triple electric series and charging by friction. I think I spelled that completely wrong. Negatively charged. And it's charged via friction. Now, when the electrophorus was brought near the base plate or placed on the base plate, somebody had to touch it with either their finger or their knuckle or some other kind of grounding. In one of the videos I linked to, they had a little grounding stick that they used. And the reason there's a shock there is because the extra electrons at the top of the plate. So we know when we bring the plate near or put it on, we know when we bring the electrophorus, the metal plate, and put it onto the plastic base, we are polarizing. Okay, so let's start with polarizing. So first, the metal plate becomes polarized when it's brought near the base plate. Polarized when near the base plate. Now, when we touch the top of the metal plate, we ground it. And when we ground it, that means those extra electrons that were hanging out on top from the polarization, right? Because on the bottom of the plate, we're left with more positive charges, and on the top of the plate, we're left with more negative charges. So when we touch the top of the plate, those negative charges have a way to escape. They escape through our hand. So when those extra electrons are at the top of the plate, they move to our finger. That's why we felt that shock. So, a couple of things. When charging by friction, we end up with two oppositely charged objects. And when we charge by conduction, we end up with the same charge objects. Right? Two positives or two negatives. So what's unique when we charge by induction, basically we're moving charge, right? We're making it move from one place to the other. We're inducing it to move. The charge of the object will depend upon the method of moving the charge. So we started with a negative base plate, and we ended with a positive aluminum plate. We're going to see that that can change based on how we go ahead and we perform the induction. So for instance, let's take a look at the next page. And we see here a process that's very similar to what you saw in the videos. So I want you to go ahead and take a couple minutes and explain what you see happening in these diagrams. But then we can also charge by induction in another method by having two spheres. So I also want you to explain this, and we're going to talk about it in class later.